Hello everyone. In this video, we're going to talk about the highest common factor, the lowest common multiples, and prime factorization with all the different cases. Sorry for the interruption. Okay, so here we got the HCF and the LCM of 84 and 60. They need us to write it as a product of the prime factors first, definitely, and in order to find the HCF and the LCM. Let's do this. I'm going to use here the division, the repeated division method for 84 and the same thing also for 60. All right, we need to divide only by prime numbers. So here I'm going to divide by 2, gives me 42. Divided by 2 is 21. Divided by 3 is 7. Divided by 7 is 1. Once I reach the 1, this means that I finished. So 84 is actually equal to 2 to the power of 2 times 3 times 7. While 60 is going to be divided here by 2 to give us 30, by 2, 15. By 3 is 5, by 5 is 1. So 60 is equal to 2 to the power of 2 times 3 times 5. Now I need to find the HCF and the LCM. How can I find the HCF and LCM? HCF, write only the common prime numbers. The common prime numbers. 2, is it only? Is it common? Yes, it is common. 3, is it common? Yes, it is common. 7, is it common? No. 5, is it common? No. So it is just 2 times 3. Oh, that's it, mister? No, I just wrote the common prime numbers. But which index, which power am I going to take? For the highest common factor, take the lowest power. Again, for the highest common factor, take the lowest power. So here, 2 to the power of 2, 2 to the power of 2. Oh, mister, they are the same, so just take the 2. 3 to the power of 1, 3 to the power of 1, they are the same, so just 3 to the power of 1. So now I have 4 times 3, which is 12, and this is the highest common factor. What about the LCM? In the LCM, we need to take the common once and the uncommon also take it. So common, the 2 is common, yes, take it. The 3, the 7, the 5. So that's the difference between the LCM and the HCF. Now let's worry about the powers. In the lowest common multiple, I take the highest power. So for the 2, I have here 2 to the power of 2 and 2 to the power of 2. They are the same, mister. So it's just 2. But if I'm saying if this was 2 to the power of 3 and the others 2 to the power of 2, كنت هاخد ساعتها I was going to take 2 to the power of 3 instead. But in this case, both of them are the same, so it's just 2 to the power of 2. Also for the 3, 3 to the power of 1, the highest of them, they are equal, yes. 5 and 7, both of them, there is nothing common, so it's just to the 5 and to the 7. You multiply that, it's going to give you exactly 6,420. So the lowest common multiple is 420. And this is how we find the highest common factor and the least common multiple of two numbers, but these are not the only cases. We've got here a question that says to you, HCF of 90 and Y is 15. LCM of 90 and Y is 450. Find the value of Y. There is a rule that you must understand. The two numbers that you're getting the HCF and LCM for, if you multiply them by each other, like 90 times Y, which is 90Y, they give you the same answer as multiplying the HCF by the LCM, which means 90 times Y is the same as 15 times 450. Let's do it on the calculator very quickly. 15 times 450 equals 6,750. So 90Y equals 6,750. 6,750. So what is Y? Solve the equation. Y equals 6,750 divided by 90. 6,750 divided by 90 equals 75. And this is y, the other number. So just multiply the two numbers by each other. 90 times y, which is 90y, equals HCF times LCM, which is 15 times 4,000 times 450. Solve the equation for y. Thank you. Next example here, they're saying to you list all the factors of 255, given that the fact that 255 is equal to 3 times 5 times 17. All right, they gave you here the prime factors, but they're requesting all the factors. The first step, so I've got here first, second step, third step. First step for the factors, we know that any number in the world has two factors, one in itself. Definitely. I have here 1, 2, 5, 5. This is the first step. All right, the second step listed the prime factors that they give you already. 3, 5, and 17. The third step, you write the product of the prime factors, but in pairs. You write the product of the prime factors, but in pairs. What do you mean, mister? I mean, you take the 3 and the 5 together. Oh, 15. And you take the 5 and the 17 together. 5 times 17. Okay, that's 85. And you take the 17 with the 3 together. 3 times 17, which is 51. So now we took the 3 and the 5, we took the 3 and the 17, and we took the 5 and the 17. That's it. So the factors of 255 are 1 and 3. Let's put them in order. 1, 3, 5. We got also 15, 17, 51, 85, 255. Mister, if I made a mistake in the order, would it be wrong? No, they say in the mark scheme, accept these factors in any order. Let's continue. Now they're saying it to you, a equals 3 to the power of x times 2 to the power of 4 times 7 to the power of y, but they want you to write 6a, not a, as a product of powers of its prime factors. Oh, 1 second, mister. 6a means it's the same as a. It means the same as a, but it's multiplied by 6 at the end. So they wanted the same as a, which is 3 to the power of x times 2 to the power of 4 times 7 to the power of y times 6. Oh, but the 6 I needed as prime factors. I don't want to write 6. What are the prime factors of 6? It's 2 times 3. Here you go. 6 divided by 2 is 3, divided by 3 is 1. It's 2 times 3. So I'm going to remove the 6, and instead of the 6 that they want me to multiply at the end, I'm going to multiply by 2 and by 3. Okay, that's it? Not really. You just need to simplify. The 2's take them with each other, and the 3's take them with each other. So instead of 3 to the power of x, as if you're saying 3 to the power of x times 3. What is 3 to the power of x times 3? 3 to the power of x times 3 equals 3 to the, which is 3 to the power of 1. We agreed if the two bases are the same, we add the indices. So it's 3 to the power of x plus 1. Okay, so 3 to the power of x plus 1. Done with the 3. What about the 2, mister? All right, it is 2, so times 2 to the power of 4 plus 1, because it's 2 to the power of 4 times 2 to the power of 1, which means 2 to the power of 4 plus 1, 2 to the power of 5. Now I finished this. Definitely, I don't need you to cross it in the homework. I don't want you to cross them, but just for you to see. I have only 7 to the power of y left. That's it. Thank you so much, and see you in another video.